What's up, everybody? This is Coach Sharf. Welcome back to my YouTube videos for Algebra 2. Our video today is showing us some real-world exponential growth and decay problems, including a couple problems from the worksheets that y'all have to do. And the point of this is, again, you should be able to, identify the parts of your formulas, what's your principal amount or your initial amount, what's your interest rate, things like that. But just to remind y'all how to punch it in the calculator, just to avoid any confusion with that, and how to do it for the different formulas, because each formula you got to punch slightly differently into your calculator. So let's go ahead and jump in. Okay. And so this is what I'm going to do. Okay, we're going to start with actually, I'll tell you what. We'll start with this real quick. Again, these are your four formulas. Okay. These are your four formulas: your regular growth formula, your regular decay formula, the compound interest formula that's added the n for the number of compounding periods, and your continuous compounding formula. And just so we have it on video, so again, y'all can pause it and write it down in case you don't have it. If we come back here a few slides for the number of compounding periods, when we're doing those, here they are. So you got yearly n is 1. But again, when it's yearly, you could just use the regular growth formula. Semi-annually n is 2, quarterly n is 4, monthly n is 12, daily n is 365. All right, so let's go back to our worksheet. So our first worksheet, again, this is it. It's in your assignment in Canvas. Both your worksheets are. So for numbers 1, 2, and 3, that's just either going to be a regular growth or decay formula. Number 4 is going to be compound interest, but I'm going to wait to show that on the second worksheet. But we're going to start with number 5, because number 5, outside of that number 4 with the compounding problem, looking at number 5, we should be able to answer everything else we have on here. Okay. So population of Boomtown is 475,000 and is increasing at 3.75% each year. When will the population exceed 1 million people? First thing we'll notice is, in these previous problems, we were given initial population, growth rate, time, and we got to find the population. Okay. Initial amount, that's actually decay rate because it's losing money. Time, amount at the end. All right. So the first 3 are pretty similar. Again, 4 is going to be similar as well, except it's the compounding interest formula. So 1, 2, and 3 are going to be our regular growth formulas, growth or decay formulas. 5 through 9 will be as well, but they're a little different. So it tells us our initial population, tells us our rate. It says, when will the population exceed 1 million people? That's our A. So we got to find the nearest year. So we got to find T. And again, we could do that. We can get an exact number using logarithms. But we haven't learned logarithms yet. So we're pretty much just going to have to what I call plug and chug. So put this on the whiteboard. Again, the kind of idea behind this is this. All right, we're still going to use our regular growth formula. It actually should be A equals P 1 plus R to the T power. I'll tell you what. In class people, y'all are going to get a little bonus just in case you need. I'm going to unfreeze this just so y'all can see it. Okay. So y'all kind of follow along. So P is 475. Number 5 on the first worksheet. Yeah. P is 475. R, again, being 3.75%, we got to move that decimal 2 spots to the left. So 0.0375. T is what we're looking for. And again, A, we want to be 1 million. So again, if I could plug all that in. We'd be missing t. I can use logarithms to get exactly what t would be. Okay. But, we're going to kind of tweak it a little different for what we want to do. Okay. So if you look at the problem, it said, when will A exceed 1 million people? So we got to assume there's a very, very small chance that we'll hit exactly 1 million people at the end of 13 years or 25 years or 40 years, whatever it is. So A is probably not going to be exactly 1 million. When it crosses 1 million, for a whole year, it'll be slightly over 1 million. So what we're going to do instead is we're not really going to put A. Okay, we're going to have our 475. We're going to do our 1 plus, move this up, 0.0375 to the t power. All right, and then for all the problems like this where we got to plug and chug, I need to see this formula. Okay, all the problems where we got to plug and chug, I need to see this formula. So give me just a second. So again, we got to use a little logic here. If we're growing at less than 4% per year, right? 3.75%. And we got to more than double from 475,000 to 1 million. It's probably going to take a few years. It's not just going to take 2 or 3. It's going to take a good amount of years. Okay. Each class period kind of started with a different guess, but what we kind of settled on with the most common number was 15. Okay. So we're going to plug and chug with t equals 15. So this is where it's going to kind of be like our, the problems 1 through 3, and even the ones on 5 through 9 that aren't like this. I now know what t is. Okay. I now know what t is. So now we can almost kind of say, all right, now I'm looking at this again. I know this is 15. What's A? So I got to calculate A, and I got to look for it to be, again, just over 1 million. So I didn't really do this when I did in class because we're just assuming we're plugging in 15 here. But if you want to rewrite this, I'm going to have to try to kind of shrink my handwriting a little bit here. 0, 0, 0, 1 plus 0.0375 to the 15. Okay. And again, the reason why I did this because on the parts of this first worksheet where we don't have to plug and chug, I need y'all to show me actually plugging it into the formula and then how you would punch in the calculator and get your answer. So, on the plug and chug ones, I need to see this. You don't have to necessarily show me the 15 coming in here, but then on the non-plug and chug ones, so for 1, 2, 3, even 4 with the compound interest, let's see here, number 6, part 2, 7's plug and chug, 8, there's 4 parts, so 8 parts 1 through 3, and then 9 part 1, where you actually know t. I need to see this in terms of this, all right? Again, that might be a little confusing, so maybe I'll just go back and show one of those so y'all see what I mean. So, for the plug and chug ones, I definitely need this, what I have started, so y'all need to show me that. And then when you do 15, again, you actually got to show me how you're going to punch it in your calculator. So if you have a regular scientific calculator, it's going to be 475, parentheses 1 plus 0.0375, caret 15 equals. Let me pull mine up so y'all can see it. 475, parentheses 1 plus 0.0375, caret 15. All right, so hold it up to the camera. Make sure I got my finger on the right arrow. 475, 1 plus 0.0375, parentheses, caret 15. All right, and then you would hit equals. In your iPhone or your Android, it's going to be a little different. You can't just type in the whole formula and it'll do the work for you. So you basically got to type it in terms of order of operations. So again, if you sit there and think about it for a second, it's pretty much laid out for you. Here's some math I got to do in parentheses. All right, so there's your P. And then whatever you get here, you're raising to the 15th power. That's your E, so you need to do that next. And then you're multiplying 475 by whatever you get here. So this is your M. So basically, you got to do it in that order for your iPhone. So, or again, your Android. So your phone, you're going to do 1 plus 0.0375, right there. Hit equals. Whatever your phone spits back at you, that's what I'm going to underline. So it spits back at you 1.0375. You then got to do to the 15th power. So you're going to hit that X to the Y button. All right, you got to find that X to the Y button on your calculator. 15 equals. And it'll spit back out at you. Let's see here. Can't use my iPhone because I got Zoom open for my other class. So let me show you on the calculator how you do it in your iPhone. All right, so we got 1 plus 0.0375. Okay. 1 plus 0.0375 equals. You hit it. All right. So again, you would hit that XY button on your calculator. For me, all I got to do is come over here and hit caret 15. So it's raising that 1.0375 to the 15th power, gives me 1.737087043. All right, you need to leave that whole decimal in there, but I'm going to round it to 3 decimal places just so I don't have to write as much. So 1.737 is what spit back out at me. And then I'm going to multiply that. I got to carry it down the line because I ran out of room. So I got to multiply that by 475,000. Hit equals. All right, so now I'm taking my answer times 475,000. Got it in there, hit equals. Gives me 825,116.34. But since we are talking about human beings, we're going to round up to the next whole human being. So 825,117. You get the same thing up here if you just punch that in. All right. So that's a pretty good start. You know, we're up to 825. We're still not quite all the way to 1 million though. So again, use some logic here. You say, you know, it's since we're still only growing less than 4%, it's still probably going to take more than a year or two to get this up over 1 million. So then let's say T is 20. All right. So again, since I'm running out of room, this is where y'all need to really listen close. Since I have my calculator, this is what I would be using. So I'm going to, again, you don't have to necessarily write calc, but I'm going to write all this again because this is what I'm punching into my calculator. If you were using your phone, you would rewrite all of this, except now here you would do 20. It would give you something different here, I believe, 2.066, 2.0, maybe it's 2.088. I think it might be that. And then times 475 and whatever it gets you. Okay, but I'm just going to do it here. And again, all I got to do is replace. Don't scratch this out where you already wrote it. Again, I shouldn't have to say that, but you would scratch that out and replace it with 20. So 475, 1 plus 0.0375, caret 20 equals, again, you punch that in. Even if you did it here, you get 991,872 and some decimals, so that would round up to 73. So we're very, very, very close. All right. Again, if you want to think about it logically, we're only 8,127 people away. You know, if we round up this to 992,000, round our 3.75%, even if we round down all the way to 3%, 3% of 992,000 is probably going to be more than 8,000 people. Let's punch in our calculator just to be sure. So 475,000, 1 plus 0.0375 to the 21st power equals, when you do that, it's going to be 1,029,000. We would round up to 68. So, all right, we worked through this whole problem. I for sure need to see this, okay, on the plug and play problems. I for sure need to see this. And again, I would like to see your thought process. So again, if you did what I did, I would like to see, you know, I showed you plugging it in here, but you could have, you know, T equals 15 over here. So I guess let me kind of edit that. So I would like to see all your entire thought process. So I'd like to see that, you know, if you did it in your iPhone, that one, and all, you know, and these two. So I would like to see all your work, but if you want to clean it up a little bit, I for sure, without a doubt, need to see that one and the last one with your answer. All right. So there's number 5. Okay, and then like I said, let's stop sharing. Let's pull the worksheet back up. So again, number 5 would be like that one. The first part of number 6 would be like that one. 7 would be like that. The last part of number 8 would be like that one. And the last part of number 9, if I can kind of get it down there. So let's redo this. All right, so again, 5, first part of 6, 7, last part of 8, last part of 9 would all be like that, the plug and play, quote unquote. Okay. Again, 1, 2, 3 are just regular growth and decay. 4 would be compound interest. And then second part of 6, you know, here, there's P, there's your R, there's your T is 100. So you just calculate and put it in. I'll tell you what, let's show that one too. So y'all could just see a regular one where you already have P, R, and T. Okay. So population of Leavetown is 123, decreasing to 2.375% each year. What would the population be 100 years from now? So let's pull back up the whiteboard. So again, for that one, if we want to, yeah, I'm erasing all this for a reason because I want to leave what's on the left up there for the most part. Instead of just clearing the whole thing out. All right. So it said population of Leavetown is decreasing. So we know we're actually now going to use decay. All right. So 1 minus R, P was 123,000. R was 2 points. Ooh, I don't have it pulled up. Let me pull it back up real quick. I forgot that it was 2.375, I believe. 2.375. Okay, just making sure. All right, so 2.375, which again, we're gonna move the decimal spot 2 spots to the left. So 0.02375, T is 100, and A is what we're looking for. So again, you don't necessarily have to do this. You can kind of just identify them in your problem, but I do need to see this. All right, A equals 123,000, parentheses 1 minus 0.02375 to the 100th power. I need to see the setup. And then again, whichever way you're going to punch in your calculator. So again, I'll show both. So for your iPhone, or your scientific calculator, excuse me, 1 minus 0.02375 caret 100 equals. For your iPhone or Android, let's see here, it would be 1 minus 0.02375 equals, and that would spit it back out at you 0.97625. You would hit X to the Y. 100 equals, let's see what that would give you. It would give you, I'm going to move it over here. Should give you this 0.090386733. Again, we'll round it to 0.0904. I'll do 2 decimal places or 4 decimal places. I can't count today apparently. And times 123,000 equals, but you leave the whole decimal in, multiply it by 123,000. divide, multiply. And we get 11,117.56. So we'll round that up to 1,117 or 11,118. Can't talk. All right. So, again, I need to see this and whichever one of these that you do for. So that's going to be for 1, 2, 3, 4 is compound, which I'll get to in a minute. 6 part 2. This is 6 part 2. All right. So there's your answer for that. 8 parts 1 through 3. And then 9 part 1. So I would need to see again, this and this or that, whichever one you did. All right, so that's the first worksheet. The video's gone a little long, but just trying to make sure y'all know how to do it. So let's move to the second worksheet real quick, and we'll do 2 on that one, and those hopefully go a little quicker, and we'll be done. So stop sharing again. Actually, I didn't need to do that, but whatever. All right, let's move. Come on. Stop. Move that down there. All right. So now for the compound. So this is what I'll do. Since you got 2 quarterly, I'll do number 5. I'll do that one since it's quarterly, and then y'all could do the other quarterly one. And then I did number 7 in class, so I'll do that one again. So find the final amount for $1,800 investment at 8% interest compounded quarterly for 6 years. Got to use the compound interest formula. Again, for number 1, you could use the regular growth formula. If you want to use the compound formula, since you're doing annually, and would just be 1. We're going to do number 5. Okay. We're going to do number 5. Come on. All right. So A equals P 1 plus R over N to the NT power. All right. P was 1,800. R was 8%, so 0.08. T was 6 years, and N was compounding quarterly, so N is 4 again. Let me make sure I didn't flip that 8 to 6. So I'm tired, and my memory's not what it needs to be right now. Yes, I did that right. All right. So again, for the compound interest now, this is what I need to see. Again, you don't necessarily have to write this, but I need to see this. A equals 1,800, 1 plus 0.08 divided by 4 to the 4 times 6 power. So I need to see that. And again, 2 different ways to punch in your calculator. So for your regular scientific calculator, 1,800 parentheses, we're going to have to get a lot of sets of parentheses going on here. 1 plus parentheses, a second set of open parentheses, 0.08 divided by 4, close parentheses, caret. Again, if you do 4 times 6 is 24, you can just put 24. But like I said, I know one of the problems is daily, so it'd be 365 times something. So we'll just do parentheses 4 times 6, close parentheses equals. All right, and again, we'll punch that in your scientific calculator to calculate. So your iPhone calculator or Android calculator, again, whichever one you're using is going to be a little different. So we almost got to look at it now like we punched in the iPhone calculator, okay? You got to do this inner set of parentheses, then the bigger set of parentheses. You would need to kind of go ahead and do this, but the way we're going to have to punch it in, we're actually going to have to do the exponent part first and then put this in parentheses. So, exponent slash parentheses and then multiply. So how's it going to look? All right. So we would do 0.08 divided by 4 equals. It's going to spit back out you 0.02. That one actually divides pretty clean. Okay. So that's what you punch in, hit equal, spits back out 0.02. You then add 1. Of course, it's going to spit out 1.02. All right, again, then you hit the X to the Y button. Now you're going to hit parentheses 4 times 6. Again, if you know that's 24, just type 24. You're going to do open parentheses 4 times 6. When you do close parentheses, it's going to spit out at you 24. But it's not saying 1.02 to this power is 24. What it's saying is you're now taking 1.02 to the 24th power. The XY should still be highlighted. Then you hit equals. It'll spit out what? 1.608437249. Again, leave the whole decimal. I'm going to use 1.608 times 1800 equals 2895 and 0.187. So now we're dealing with money. It's a little different. So I'm going to do 2895 and then round it to 19 cents. Okay, 0.187. So I'm rounding 19 cents. And you should have gotten the same thing there. So again, I need to see for those first 6 problems, I need to see that and then this or that, whichever one you did. All right. Take a second, catch my breath. Let y'all catch your breath, pause it, and then we'll do the continuous compound. All right. So one more problem, continuous compounding. Appreciate y'all hanging on me with this video. Just want to make sure y'all got everything good to go. So 7 through 10, it's all compounding continuously. So we got to use that continuous compounding formula. We did number 7 in class. So again, that's the one I'm going to do now. So let's clear this out. So again, that continuous compounding formula is a little different. A equals per, right? P times E to the RT power. That E is that Euler number, that natural number I talked about in class. Again, you know, I can't tell you off the top of my head how they found it. You know, I know the Greeks were sitting there playing with circles and eventually figured out if you divide the circumference by the diameter or 2 times the radius, you know, whichever way you use it, or if you divide the area by the radius squared, you kept getting that 3.14159, whatever number that they designated as pi. So I can't tell you how the guy came up with E, but again, it's about 2.718. But you have E buttons on your calculator, both your calculators, like you do with pi, so it's easier to deal with E. All right, so problem number 7 was $300 invested at. Again, I forget which one's 4, which one's 5. I keep forgetting. I'm so tired. 5% interest for 4 years, compounded continuously. So R is going to be 0.05 for 5% interest. T is 4. So for these last 4, I got to see A equals 300 E to the 0.05 times 4. So I definitely need to see this. And then again, whichever calculator you're going to use. So for your scientific calculator, it's going to look like this in the display. At least, again, mine, the TI 30X. Yeah, I don't know if that's supposed to be Roman numeral 2S. I've never figured out, or if it's just supposed to be IIS. But anyway, E to the 0.05 times 4. And again, how we're going to get this, we're going to hit that second, or shift, whichever one yours is, and then ln. So can we look at mine? I got second, hit the ln. There's the e to the x above it. So I'm going to type 300. All right, I got 300 in. Then I'm going to hit my second ln. See the e caret parentheses pops up. And then just 0.05 times 4. And I close parentheses. Honestly, don't even have to close the parentheses at that point. So you would do that and hit equals. If you're doing it on your iPhone, you would do one of the phones. I think it was a Samsung. Somebody had it and it did it a little differently. But I'll get to that in a second. So 0.05 times 4 is going to give you 0.2 is what's going to spit out. And again, on the iPhone, I know it does this on the iPhone. I'm pretty sure it does it on the Android too. Maybe the Android's different. You got to go find that E to the X button. All right. When you hit that E to the X button on your iPhone, it's automatically going to spit out 1.221. Okay. If when you hit the E to the X button, the same thing pops up like we had here. All right. Then you just type in the 0.2. All right. So again, iPhone, if you hit E to the X, it'll automatically do this. Some of the other phones, you multiply that, get 0.2, you hit E to the X. Again, E caret, that might pop up. Then you just, put the 0.2 in there and hit equals, and you'll still get the 1.221. Again, you want to leave the whole decimal. I'm not going to even pull it up, but you want to leave the whole decimal. I've just rounded it. Times 300 equals. And then either way, you're going to get, I believe it's 366.42. It is. Because again, we're talking about money. So $366.42. So again, for the last four on that worksheet, I need to see this for sure, and this or that. All right, try to get through that as quick as I could and being as thorough and comprehensive as I could. If you still got any other questions, again, let me know. Good luck on the quiz. And like I said, the worksheets aren't due for another few days after that. So, good luck on the quiz and just keep working on the worksheets and make sure you get them in on time. Till next time, this is Coach Sharf signing off.